Hi, this tutorial is going to show you how to create marathon problems and contests. So let's start from creating a marathon problem. This is done in a tool called MPS QIS. Oops. This is the URL to launch this tool. Okay, let's launch it. Now I log in using my non-admin handle. Okay, done. Now I go to Problems, Main Loan Problem Room. Here I press Create Problem. I type the name for my problem, the memory limit. I can type the code length limit if I want, and I select round type as loan problem round. Now I press submit. Okay. Now I just go to main loan problem room again. Here I can see my new problem. Let's check it. I see a bit more information here. First of all, I can and I have to select at least one category. Let's select simple math. We can save any changes using save statement. Now, if I want competitors to implement any methods, I need to add them here. Let's add a method called guess. It takes no parameters and returns an int. Note that I use Java method names, parameter, types, everything as in Java. Okay, it's added. Let's save it. The method display test case that you see here is conventional. You should leave it here and don't delete it. Generate preview shows the current statement. We now see that we have a method guess that competitors need to implement. Introduction is some HTML that shows the actual problem statement. Let's copy it. Oh, we have some problem statement here. We can also add notes, constraints, if we wish. Okay, assume we have a problem statement that is completed. We want to proceed further. Now we need an administrator to approve our problem. Let's do that. I log in under my admin handle. And I approve this problem. Also, I add a tester here. This is yet one more account of mine. Awesome. Let's get back to my initial non-admin handle that I used to write this problem. We now see more tabs here, in particular test data, solution, and so on. Speaking about test data, in Marathon each test is characterized by just one string. It's called test seed. Marathon tester can interpret seed as it wishes, in any way. Let's assume seeds in this problem are just some integers. Well, we can add some test cases here. This is seed 1, this is seed 2, this is seed 3, and so on. Test cases can be of three kinds: example test cases, provisional test cases, and system test cases. Example test cases are displayed in the statement. Provisional test cases are used for tests during the contest, and system tests are used for tests after the contest and to determine final rankings. If none of example and system are checked, then this would be a provisional test case. So these three cases are example ones. These three cases are provisional cases. And these three cases are system cases. Everything needs to be saved. Now, there is an option to add cases from file. It's useful when we want to add a bunch of cases. To do that, create a file, put the number of cases you want to add, for example 5, then put their seeds: 10, 11, 12, 13, 14. Okay. Then type the file here. If we check as system, those would be system test cases. If we don't check, those would be provisional test cases. Let's check. Okay, we have 5 more system test cases. Let's save. Next thing, solution. Well, it's not actually a solution, it's a code that runs tests and calculates scores. It's always Java code. We have 4 methods here. Check data is purely conventional and does nothing. It just needs to be included. Display test cases can display annotations for example test cases. In this case, the annotation is just seed. We can see it here. Example 1 seed 1, example 2 seed 2, example 3 seed 3. If we change text here, it gets changed here. Pretty simple. Next, the main method is runTest. It works with a certain class called longTest. So this class has many useful methods. Method getTest allows to get the seed of this test case. We can parse it, and now we have a seed. Let's create a random number generator with this seed and generate an integer from 1 to 100 using this random number generator. Okay, we have generated some test case. Of course, real generation would be more complicated. By the way, I forgot to mention, the purpose of this method is to run a single test and return score. That solution produced on this single test case. Okay, now let's call the solution. This is done in several steps. This sets memory limit. This would be 10 seconds. This calls the actual method. Note that our method is called guess. So we just type guess. This checks if everything was fine or not. If it was not fine, this report some information to our user. In this case, it's an error message, but in fact we can use this method to report any information. Finally, we return zero score. Uh, let's assume zero score is very bad score. Of course, if we were not even able to call the method, it should be very bad score. Next, we attempt to get result of this method. We type get result and then method name. Again, we check if it was fine or not. Finally, we do some simple calculation to return score. Okay. So this method runs a single test case and returns score. In addition to scores on single test cases, we need to do some aggregation of scores. So there can be many test cases in a problem. For example, stock 100 cases. And we need to aggregate them to produce a single score, because leaderboard needs to display a single score. Such aggregation is done here. What it takes? It takes a two-dimensional matrix where if elements, this element of anyway, element ij would be the score of competitor I on test case j. This is the input. What it needs to return? It needs to return aggregated scores. So return I would be aggregated score of competitor I. How it's done here? Very simple, just plain average. So we iterate over competitors here, calculate the sum of single scores, and divide by the number of test cases. It can be more complicated again if we need. Okay, that's it. Next thing we should try is some actual solution. The bad thing about MPSQL is that we need another account to do that. Well, let's do that. Here is another account, and it has access to this problem. Let's add some solution here. Awesome, we have solution. Let's try to test it. We can see that it was tested and got some score. Similar here. Again, got some score, 0 in this case. We can also use system test all to test on all cases. Unfortunately, it's not possible to test on all example, provisional or system cases. Only on all cases of all kinds. If we add one more solution here and press system test all, we would also see aggregated scores generated by this method. I won't show it. Okay. Next thing we should try is creating a contest. This is done in another tool called Contest Admin Tool. Here is the URL. So we add a contest and we add a contest round. Next, we need to specify segments, its local time. Let's save some time in the past. Registration and coding needs to be the same time. We need to set registration and coding length. Again, it needs to be the same time. Let's set 1000 minutes. Intermission and challenge are not existing in marathon matches, so 0. Next, we need to add a problem. There are lots of problems in the system, so it's loading not very quickly. Okay, here is a problem. The convention is to set division 1, level 1, 250 points. It's not absolutely strictly necessary, but better to do it. Okay, it's done. And without any extra activities, the round goes live. We can see it here. Well, we can't see it here. Let's see why. Maybe 1000 was too short a length. Let's say 10,000. No. What else could it be? Marathon match. Okay, July 14 is just today. Let's say July 13. Oh, we finally have it live. Here is our problem. Okay, let's make it somewhere back in the past so that it's not shown. Okay, it's not shown. So here, this is how to make a contest live. Finally, let me speak a bit about how to upload some custom data. So obviously, in real problems, we don't generate data using random generators. We use some real world data. So this is done quite manually right now. We need VPN. Okay, anyway, so basic process is as follows. We have a certain cache, and we have some specific class to put any kind of Java objects into this cache. Let's try to do this. So let's copy the classes we need. And let's copy the old sample code. Okay. So basically it works as follows. First we create some special class, persistent cache. Here we use the name of our marathon problem. Next we set certain version. It's fine to set one also, always. Finally we can put any objects to this cache. For example, so this way we put any kind of data to this cache. Next, this code is to be compiled. Run. Now it creates a certain structure here. This folder yet one more number guess. It needs to be copied to all farm processors. For example, and so on, to all farm processors. Also, each farm processor in processor cache has a file called IDs. Also, we need to add a specific line that looks like this. Okay, this also needs to be done at all farm processors. Once this is done, we can get this data from cache. Let's see how it's done in another problem. Okay, here is an example. So we get an instance of long test writer cache, set version for it, and then just the method cache get can get any object for us. So this is object name, and we need to explicitly cast it to whatever we know this object has a type. Okay, that's probably all. Thanks for listening, and I hope it's at least a bit clear. Goodbye.